Hi everyone, welcome to another computer science tutoring video for the Baylor University Tutoring Department. In this video, we will introduce the concept of the heap and dynamic memory in C++. First, before we learn about dynamic memory and the heap, let's take a quick overview of the stack. The stack is the region of memory within the computer that is used to statically allocate memory in programs. This is a linear data structure. Static allocation means that the necessary amount of memory is reserved prior to the program runtime, specifically during compile time. When a program is compiled, the compiler parses the code and can determine based on variable initializations how much stack memory will be needed. So let's say that the 3 lines of code in the slide are in a program. When the compiler parses this, it would determine that 4 bytes need to be allocated from the stack for the int x, 200 bytes for the 100 shorts, and 24 bytes for the 3 doubles. As you can see, this can be determined ahead of time by the compiler. This is how you have been writing programs up to this point. All arrays that you have created have been statically allocated with some fixed size, and your memory has come from the stack. When using stack memory, you have also not had to think about manually allocating or deallocating this memory, since it is handled by the compiler. This will be different when using memory from the heap. The heap is the other structure where memory is allocated in programs. Unlike the stack, the heap is not necessarily a linear structure and can be more described as a blob of memory that can be pulled from by the programmer. Memory from the heap is dynamically allocated during runtime when the programmer uses dynamic memory allocation in their code. Unlike static memory allocated from the stack, with memory from the heap, we as the programmer must also deallocate this memory when we are done using it, else it can cause something called a memory leak, which you will learn more about later. In the example shown, you can see the syntax of dynamic memory allocation. We need to create a pointer variable, then use the new keyword to allocate memory from the heap and set the pointer to that memory. In the case of pointer D, after that initialization line of code, 5 doubles will have been allocated from the heap in an array. D will point to the first double in the array. We will see more examples done with this in the next video. So as mentioned in the previous slide, when using dynamic memory from the heap, we as the programmer must deallocate this memory once we have finished using it to avoid something called a memory leak. If we have a long-running program in which we allocate a lot of memory from the heap, but never clean it up, even when we are done with it, we will end up with many large memory leaks that slow down the user's program as more and more of the machine's RAM is taken. To avoid this catastrophic result, we must get in the habit of deallocating dynamic memory, even if we are writing small programs. When you are finished using the memory, you should use the delete keyword to deallocate it, then set the pointer to the null pointer keyword so that our pointer isn't still pointing to that memory despite it getting deallocated. You may have been wondering at this point what reason we would have to use dynamic memory since it is so much more involved than using the stack. Well, previously, we have always had to give a fixed size for all of our arrays, which isn't a scalable solution in most programs. This example on the slide shows how we can create arrays with a dynamic size known at runtime. Here, the user chooses a size value, then we allocate a block of memory from the heap based on the user's inputted size for our array. Of course, after using this array, remember to deallocate the memory, something I'm not showing here for brevity. So that wraps up our very short video on the heap and dynamic memory in C++. We learned that we have typically been allocating memory off the stack statically up until this point, and that this memory is managed behind the scenes for us. Next, we learned about the heap, which is a chunk of memory that can be pulled from dynamically while the program is running, but must be manually managed. Stay tuned for the next video in which we will have an example using dynamic memory in C++. I hope you found this video really helpful. The concepts and information presented in these videos will be true no matter which computer science course you are taking. However, the concepts presented in this video are referencing material currently covered in Baylor University's coursework. Remember, if you are a currently enrolled Baylor student, we offer free tutoring services. Our tutoring center is located on the first floor of the Sid Richardson building. You'll find all the details you need about these services on our website, www.baylor.edu/tutoring. You may schedule a free 30-minute one-on-one tutoring session online or just drop in during any of our business hours. For more information about our current services, please visit our website. Thanks.